You do this without thinking about it. The model answers, and you ask it to check its own work. Or you have it critique itself and rewrite. It feels like accuracy you get for free. Someone tested that properly. 36 comparisons at equal token cost. Self-inspection won 0 of them. Here's the chart the study fits inside. One chain of thought on a small model. 297 tokens, 70%. Now you ask the same question 16 times and keep the most common answer. No new idea. 81%. That curve is what more tokens buy you on their own. A method has to land above it to be worth your budget. So drop self-refine on, at its own measured cost. Why is it under the line? One correction first, because this is the part people invert. Chain of thought is not the loser. Which side is it on? Both of them. The winner is many chains, counted. The loser is one chain the model then inspects. So what is the fair question? Not whether self-criticism beats one attempt. It does, because it writes 6 times more. The fair question is whether it beats spending those tokens on more attempts. That is the comparison you almost never see. And every token counts. Critiques, reflections, debate turns, verification. If the model generated it, you paid for it. 7 methods. Models at 1.5, 3 and 7 billion. 2 mathematics benchmarks, 150 questions each. 36 paired comparisons, each with a bootstrap interval and a home correction. The study that first made this argument had none. Here are all 36 against the equal cost baseline. 0, reliably better. 10, reliably worse. Which 10? Every one is a method where the model inspects its own output. Those methods run 18 of the 36 comparisons. All 18 came out negative. You could still blame the cost matching. One method removes that doubt. Best of N draws 8 answers, then asks the model which is best. Now take those same 8 and count them. Same model, same samples, same tokens. Only the last step changes. Which one wins? Counting. Every setting. 8 points, 11 points, 17.3 on the 3 billion model. Your next thought is mine too. Was the model just too small to judge? Partly. At 7 billion, the penalty drops to 2 points, and both intervals contain 0. But look at why it closed. The verifier overrules the tally less and less. 30 questions, then 17, then 8. And when it does overrule, it is still usually wrong, right about 20% of the time, never near half. So choosing stops hurting as the model grows. Does rewriting? No. At 7 billion, self-refine and a forced reflection are still 3.6 to 10 points below the baseline. Reconsidering an answer is a worse use of your tokens than another attempt at every size they could test. Then the result I keep thinking about. Reflection, exactly as published, decides for itself when to stop. It asks the model whether its answer is correct and reflects only if the answer is no. How often do you think that fired? On the smallest model, never. Not one question on either benchmark. It judged itself correct every time. It quietly became one chain of thought and scored well because it had turned cheap. 3 things worth keeping. More text raises accuracy on its own, so beating one chain of thought proves nothing. At a fixed budget, asking the model to judge its own work is where it loses. A tally never has to recognize anything. And a method that chooses when to run can stop running without telling you. Now the Part 1 OU. This is a preprint from yesterday, one implementation of each method not peer-reviewed. The models are small, 1.5 to 7 billion. And I did not reproduce this, I read it. Here is the objection that bothers me most, raised by the author himself. Both benchmarks are mathematics. An answer is one value you can compare, exactly what majority voting needs. On open-ended work, there is no majority to take, and this baseline does not exist. And a verifier trained to verify does beat voting at 7 billion. What loses is the free self-check, not the idea. So next time you are about to add a review pass, ask what those same tokens would buy you as another attempt. Thanks for watching this far. If it was useful, a like helps this reach the next person about to add a critique loop that costs more than it returns. Tell me in the comments, what does your agent spend on checking itself? And if you want more, the one called What is a Token really takes the same approach. Measure. That's the lesson. There's more like it on the channel. Subscribe, and I'll see you in the next one.